so this is our first lesson in the set theory unit. So this is our first unit that you guys are going to have a actual test on. So we've talked about how the logic puzzles are going to be kind of dispersed throughout this whole course. You will see some examples of those on tests, so like one per test, and that's how we'll kind of test on those. But then the rest of the units will have a test for themselves, kind of like normal. So today we're going to go through set concept building. So this is just kind of laying the foundation. Tomorrow we'll do set symbols. On Friday you guys have a work block, so that includes whatever you don't get done for these two and some logic puzzles. So you can work on whatever you haven't done from this week. Next Monday you're going to solve problems with sets. Then we'll do some review. Then we'll do a summative assignment. So what this is going to look like is it's going to be an in-class, open book, individual assignment. So it's kind of like a quiz, but open book. And so it'll count towards that summative, that assignment mark in your grade. And that will help you figure out what you know and don't know. We'll do more review on September 17th. I'm also going to introduce that project, and then on the Friday you guys are going to have your first test, so on set theory. So again, that will include one logic puzzle question, okay, because you guys need to get used to and familiar with those. So when we talk about set theory, we start with the idea of sets. So a key idea here is a set is a collection of distinct elements. So distinct is important. They each need to be unique, so you can't have repeats. Right? No repeats. Such as people, items, or numbers. A set can have no elements, one element, or many elements. So example, for each set, we're going to give an example of an element in the set and an element that would not be in the set. So rock is as a set, that would be bands that perform rock music. So we could say something that's in the set is, I don't know, Pink Floyd. They perform rock. Something that's not in the set, we could go Kygo. They do not, Kygo is not rock. So this is, and we'll talk about this more tomorrow, another word for something that is not in a particular set is called a complement. It's not in something, okay? So if we look at N, so we named the set N, it's 10, 15, 20, 25. So we can kind of see the pattern. We're adding 5 every time, okay? So something that would be in the set, and these ... dots means that it keeps going. So something in the set would be 30, or we could use like 75 if we wanted to go way out there. Something that's not in the set would be 2, or maybe 21, something like that. Okay, so something that doesn't fit that pattern. Okay, so sets are generally going to have some sort of pattern to them. There's 3 different ways, so 3 different ways that we can write them that we call set notation. They're on the next page. Just so you guys know, set builder, so that's one of them, can only be used when the items in the set are numeric, right? So the items in the set have to be numbers for set builder. So if you get something that's not numbers, you can just write NA for that. So the 3 ways are words, so that's kind of as it seems, we explain it in words, roster, or set builder. So again, this one is for numbers only. Okay, so if I want to do the set of letters in the word sunshine, okay, so that's describing it in words, we're going to put it in roster form. So I'm going to just call it S because sunshine starts with S, so that's what I'm going to call my set. And we use these little squiggly brackets to say, okay, here's the start and the end. Okay, so remember that we can only use a set's going to contain distinct things. We don't want any repeat. I'm going to start with S, N, U, N. I got ahead of myself. And then I see an S again. So because S is already listed, I'm not going to list it again. And then I have an H, an I, an N. Again, we already have one of those, so I'm not going to list it again, an E. So those are the only letters you need for sunshine, okay? For set builder, we're going to say that that's not applicable because it's not numbers, okay? This one, it gives us a roster of 2, 4, 6, and 8. So we need to figure out a way to describe these numbers. So we notice right away that they're the even numbers. So I'm going to say even numbers between, if I choose 1 and 9, then I don't have to worry about if I use like 0 and 10, does it include that? If I just use even numbers between 1 and 9, it's a nice easy way to describe what's in that set, okay? If it gives you a letter that set is called, we're going to maintain that letter, so Q. Set builder is a little bit trickier, okay? So set builder, we need to establish the pattern, and sometimes that requires us to identify another variable. So if we wanted to pick a number that's always going to be even, I could represent that by 2, or sorry, hold on, I forgot. This needs to start with x such that. So we're going to do squiggly bracket x such that, that's what that line means. So see how that's the same below here. Roster doesn't need that, set builder does. So x such that, and then we need to say, okay, this is the pattern for x, okay? X is going to be equal to 2 times n, okay? Where n is between, actually we're going to go n is between, I didn't want a 0. N is between 1 and 4, and n is an element of the integers. Okay, so what this is saying is that I want to pick numbers. I want x to be equal to even numbers only. If I pick a number between 1 and 4, so 1, 2, 3, or 4, and I multiply it by 2, I get 2, 4, 6, and 8 respectively. Okay, so I say if I need an even number, I'm going to have to multiply some number by 2, and then I'm going to have to figure out what that number can be to fit this pattern. Okay, so it has to be between 1 and 4, and n has to be an integer. It can't be like 1.5 or 1.7 or 1.99999 or whatever. Okay, it has to be an integer. Remember, integers are whole numbers that are positive and negative. Okay, so that might be a little bit confusing, but the more we do of this, hopefully the easier it will get. Okay, our next one is we have a set called L, and it says x such that x is greater than 0 and x is an element of n. So n means natural numbers. Okay, so natural numbers are 1, 2, 3, 4, 5, blah, 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 blah. Basically, they're our counting numbers. So we'd start counting at 1 and we'd keep going. So in roster form, we can list this, remember L, okay? We can just list this as 1, 2, 3, 4, 5, blah, blah, blah. Okay, because it's all of the ones that are above 0 that are natural numbers. So again, it's not going to be a 1.5 or 1.7 or anything because that's not a natural number. So to describe this in words, I'm just going to say natural numbers. Or you could say integers greater than 0. So there's, in a lot of cases, there's more than one way to say a pattern or to describe it. So we could use one of the two of those. If I have a roster that's 1, 2, 3, and 4, okay, we're going to say natural numbers that are less than 5. Okay, so again, natural numbers are only 1, 2, 3, 4, 5, 6, 7, blah, 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 blah. They don't include 0. So when I say a natural number that's less than 5, that can only be 1, 2, 3, and 4. Okay, for set builder, because it's called H here, I'm going to call it H again. This is X such that, so X has to be greater, let's do this. X has to be between 0 and 4, and X has to be an element of natural numbers. So it has to be between 0 and 4, but again, 0 doesn't count because it's natural. So I could have also said 1 and 4, either would work. Okay, so between 1 and 4, X is an element of the natural numbers. Okay, so these set builder style is a little bit more mathy. The empty set, I'm going to call it E for empty, can look one of two ways. So it can just be that squiggly bracket with nothing in it, or it can be E equals a 0 or a circle with a line through it. Okay, so this means does not exist. Okay, so for set builder, because there's nothing in it, again, we're going to go E is equal to, I like just the empty squiggly brackets. Okay. So that's one way we can describe these set notations, describe sets, groups of things, is words, rosters, or set builder notation. The other way that we're going to look at today is in diagrams. Okay, so we're going to use some specific sets for this. So example, the set of vowels in the standard English alphabet. Hopefully you guys know all that. The alphabet, you can sing it to yourselves. So we know the vowels are A, E, I, O, and U. We're not going to put Y in because it's only a sometimes. Okay, and then all of the other letters are going to just be in the outside box of this set. So B, C, D, E, F, G, H, I is in there, J, K, L, M, N, O's in there, P, Q, R, S, T, U is in there, V, W, X, Y, Z. Okay, so I could have written all other. This could have also been all other letters. Okay, what we call this outside box is what we call the universe, and we'll go into that again tomorrow. So the universe defines all of the letters or all of the possibilities for a set to be made out of. So the letters, and then we can kind of do subsets. We can pick specific groups amongst the letters. Okay. Second example is if we have set A is 2 and 4, set B is single even digits, and then U, that universal set, is all single digits. Okay, so 2 and 4 are kind of my inside. I guess we should put commas in here because we don't want to get confused. Then single even digits. So A is part of that group. So notice how I drew us circles that kind of nest in each other. So 6 and 8 are part of B. So this inner circle is A, this outer circle is B. And then the universe, all of the single digits, the ones that we haven't done yet are 1, 3, 5, 7, and 9. Okay, so those would be all of our single digits in that universe. So we can describe sets through pictures like this. Kind of as a reminder for us, and this will help us with our set builder notation, sketch the diagram for the real number systems. Remember that we had natural numbers in the middle, so that's 1, 2, 3, blah, 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 blah. Then we have whole numbers, which includes all of the natural numbers plus 0. And then we have integers, which includes the natural, the whole, and all the negatives. So -3, -2, -1, and then everything below that. And then we have the real numbers. So that includes all of our fractions, decimals, and everything else. Okay, so that's kind of how those are nested. Natural is N, whole is W, integers is I, and then real is R. The last thing that we're going to look at today is Venn diagrams. So I'm sure you guys have seen those before, but those are overlapping or intersecting. I think that's the word that I wanted, but I thought of overlapping first. So intersecting circles that are used when two sets share some or all of the same elements. So if we look at set A, which has the letters M, A, T, and H, and then set B, which has the letters S, M, A, R, and T, okay? And then the universal set, so that's that outside box that includes all of the letters of the alphabet. We're gonna notice some overlap between sets A and B, okay? So they share M's, A's, and T's. So if this is A, M, A, and T are gonna be in that overlapping section with A and B. And then A would have H by itself, B would have S and R by itself. And then the rest of the letters would just be in that universe that we could choose from if we wanted. Okay, so for you guys for practice for today, go and read 46 through 50 in Snap, so it goes over everything that we just talked about in other words, and then do problems 3, 4, 5, and 6 on pages 59 and 60. The ones before that we're actually going to do tomorrow. It's ordered weird in the Snap book. If you guys have any questions, let me know.